Yeah, my name is Philip Greenwood, and I'm from Aspect Studios, which is it's a landscape architecture and studio. We have studios in several studios around Australia and a couple in China. And I'm from the digital studio, which specialises in 3D visualisation, in particular real-time 3D visualisation. So a little movie here. And what I want to talk to you about today is an application we've developed for viewing urban, real-time 3D urban models. That's for use by planners, and it's, in particular, it can be used as a communication tool for the public. But it also helps inform the design process as well. Yeah, so we've had about 7 years in real-time 3D. Background was a lot of our early work was with roads, so it was roads and rail, so real-time 3D visualisations of road developments. The motivation for developing the application was primarily a commercial motivation, but we also use this application internally. So we develop models, and for our internal urban planning, this application is used as well. But the way this came about was councils were looking for 3D visualisation tools to assist in planning and to communicate their planning ideas. And we were paired with a particular council, Greenwood Council in Melbourne, by the Department of Sustainability and Environment to visualise the implementation of what's called the Melbourne 2030 Plan. The Melbourne 2030 Plan is a 30-year plan that each of the councils are developing to manage development across the metropolitan areas. So we were working on this particular project, and at the same time we noticed that there were public tenders being offered by other councils around that were asking for a similar kind of tool. So we kind of thought, well, let's abstract some of the ideas and tools we've developed from this project into a software application that can be reused across different projects, and different models can be inserted into quite easily. So, well, we're a private company, we don't have a big R&D budget, and we needed to find a solution to make this highly interactive real-time 3D environment, and that's what led us to look at game engines. So the game engine basically provides us with a lot of software components that we can use without having to sort of start from scratch and write them ourselves. So yeah. The particular game engine we used for this was called Verticals. There are several game engines we could have chosen, but I guess there are a couple of reasons why we like Verticals. Primarily, it's got quite a nice development environment, so we can actually we can use this kind of visual scripting, which is what I've got in the illustration here, and it kind of proceeds like a flowchart, and that's quite nice. It's easy for me to sort of get other people who aren't perhaps quite as skilled in programming to sort of develop little proof of concepts for different tools. So I find it really speeds up development. Verticals, I mean, you can also code in a kind of traditional kind of object-oriented scripting language, or you can also build software components from C++. But yeah, it took us about the entire development phase took about 6 months last year. So I thought it was pretty quick. Just to give you a bit of an overview of how a project might be put together. Every council has different kinds of data available. They might have LiDAR surveys done, they might have a photogrammetry survey, or they might have nothing, in which case we would need to subcontract some surveys or data collection. Most councils have a GIS database, so we try and use that as much as possible. From the data, we basically build 3D objects, so a terrain model, buildings, try and get some vegetation data, and yeah, they will be turned into 3D assets via CAD software or modelling software such as 3ds Max or Maya. So we take these assets and bring them together with the interactivity tools that were developed with the game engine, and then it's deployed in the software application. The application itself is basically the real-time 3D is deployed through an ActiveX component, which we can embed in either web pages or a Windows Forms software application. In this case, it's a Windows Forms application. The Windows application is basically just a shell, and it contains a lot of the user interface. So it has the menus, the buttons, and dialog boxes, and we can basically interact with the player or the ActiveX component. Okay, so I'm just going to go through some of the features of this thing. There's a few videos. So one of the important features is being able to analyse shadows. So we have a little tool where we can calculate accurate shadows for any time or date. We usually fix the location to a particular latitude and longitude, but the user can vary the time and date. And I have these little slider bars with which they can either animate through an entire day or pick a time of day and animate through an entire year at that time of day. You can also choose a particular date. Often people will want to pick an equinox or a solstice to see what the shadows will look like for that particular time. It's got some tools for measuring, so you can just basically pick 2 points and measure like you've got a tape measure from any 2 points. You can measure heights as well. Yeah, there's a little height measuring demonstration. You can also measure areas, so you can basically draw a little polygon and calculate the area within the polygon. It handles concave as well as convex polygons, so it doesn't have to be a square or anything. You can draw a funny shape and it will handle that. Now, the viewshed analysis tool. Okay, so for visual impact, an important issue to settle is line of sight. So often you want to know if a building will include particular views. So we've got this little tool which basically gives you a map of what can and can't be seen from a particular vantage point. So what the pink colour basically is what can't be seen from the point chosen, and yeah, what you can see is what you can see. So it's quite handy, especially with you could get, say, a proposed development or a building and place that in the model, and then switch that on and off and see what the effects are on what kinds of basically what the visual impact of that particular proposed building might be. So we have a feature called layers. By layer, I basically mean a set of 3D objects. So the user can import objects in various ways and then group them together as little sets. So I haven't got a demonstration here, but you basically have a little scrollable list with checkboxes, and you basically define a layer or one of these sets and add objects to it by clicking and selecting on the object and adding it to it. In this case, we've got some building envelopes. This is actually part of the manual model, so it's possible future boundaries of how large buildings could be built to in a specified time. So, importing objects. There's a few ways to import objects. First of all, we can just directly browse and import a 3ds format object. We can import collada objects, or also output a file from SketchUp, which is basically a KMZ file, which is really just a collada file anyway. They're the 3D formats we currently support. We can, in this particular video, you can see there's